Hello. Today we'll be going over limiting reagent calculations. So for our objectives that we hope to reach by the end of this video are to learn the definition of a limiting reagent. Next up is how to use dimensional analysis and stoichiometry together to determine the limiting reagent and a reaction. Finally, we want to understand how to use the limiting reagent to calculate the amount of other reagents in a reaction. But then that points to the big question of what is a limiting reagent? Well, a limiting reagent is a substance that's completely consumed when the reaction is complete. Some real-life examples you can point to are baking a cake for a recipe. If the recipe calls for 8 eggs and 4 cups of flour, and you have the 8 eggs, but you only have 2 cups of flour, well, the 2 cups of flour are limiting how much cake you can actually make. We can also look at when you build a car. If for every one car you need 4 wheels and 1 steering wheel, that pretty much is how much that you need to make one car. So let's say that we had 8 wheels but only 1 steering wheel. The steering wheel is acting as our limiting reagent because we cannot make 2 cars if we only have 1 steering wheel. It limits how many cars we can make in one moment. So jumping from that, we can look into science, to chemistry specifically. If you have too much of one reagent but not enough of another important reagent in a reaction, you won't be able to manufacture or synthesize the needed compound that you want to get from the reaction. So in chemistry, it's very important to know what reagent might be limiting your reaction in order to have enough of the reagent to get your desired amount of product. Grams. Now we'll move on to methane. 1 mole of methane gives me about 16 grams. Then from there, from the stoichiometry, I see that I get 1 mole of methane for every mole of CO2. Then converting the CO2 into its mass, I get 264 grams of CO2 from methane. So based on both of these values that I get, I can see very clearly that our O2, our oxygen, is our limiting reagent in this case. So if we know that our oxygen is our limiting reagent, how much of the methane wasn't actually reacting in this reaction? Well, we can use our limiting reagent oxygen to actually go back into the stoichiometry and the dimensional analysis to find out how much methane is actually required for this reaction to go to completion. So once again, I see that 1 mole of oxygen is going to be 32 grams. But now instead of doing O2 to CO2, I'm going to go from oxygen to methane. And then converting the moles of methane back into grams, I get approximately 27.5 grams of methane.